ஸோ வணக்கம் நண்பர்களே. ஸோ இன்றைக்கி பார்த்திங்கன்னா நம்ம ஸ்பெக்ட்ரோஸ்கோப்பி தான் ஒரு ஆஃப் யூனிட் பார்க்க போகிறோம். ஸோ பார்ட் 1 பார்ட் 2 பார்த்துருக்கோம். ஸோ ஃபஸ்ட்டு பார்த்திங்கன்னா தென் மாலிகுலர் ஸ்பெக்ட்ரா. ஸோ the மாலிகுலர் ஸ்பெக்ட்ராவில் எப்படி எழுதுனா தென் E is equal to EE plus V plus R, then E which is called as electronic, V is called vibrational, then R is the rotational. So if EV is greater than R rotational. So if pure rotational spectrum means that should be a microwave and fair IR. If it vibration and rotational spectra, it should be a near IR region. Then electronic spectra, then visible and UV region. So in rotational spectra, so already I said then what is my rotational spectra, then microwave and fair IR region. So in rotational spectra to determine the structure of their molecules. So then rotational spectra is also called as microwave spectroscopy, which is described then electromagnetic spectrum in the range in these cases. Okay. So then rotational spectrum or microwave spectroscopy then lies between the fair IR and conventional radio frequency region. So what is the condition for resonance? The rotational spectrum motion of molecules has a permanent dipole momentum. If the molecules are not having dipole momentums, it is not possible. It should be a microwave inactive. Then example H2, then Cl2. So if the molecules having dipole momentum means the interaction should be easily give rise to the molecule. It should to be a microactive. So இது ரெண்டுமே most important. Microwave inactive, microwave active. இது மாதிரி எக்ஸாம்பிள் கேட்பாங்க. ஸோ மைக்ரோவேவ் இன்ஆக்டிவ் கொடுத்துட்டு விச் இஸ் த சூட்டபிள் ஃபார் micro inactive எக்ஸாம்பிள்னு கேட்பாங்க. ஸோ திஸ் ஆர் த மோஸ்ட் இம்பார்ட்டன்ட் கேசஸ். So then rotational spectra is also absorption molecules. It has 1% of optical absorption. Okay. So next diatomic molecules. I already said then diatomic molecules there should be two types. One is rigidity diatomic molecules and non-rigidity diatomic molecules. So in rigidity diatomic molecules, it has a definite mean distance. It may be treated as a rigidity rotator with the free axis of rotation. It can be write it as then R0 is equal to R1 plus R2. Then momentum of inertia can be right. Then I is equal to mu R0 square. Then mu can be right. This case this is called reduced mass rate. So இது நிறைய டைம் கேட்டிருக்காங்க. So by using the Schrodinger equation, the rotational diatomic molecules can be right. Then Ej is equal to this equation. So from this equation, then H is the Planck's constant. Then I is the momentum of inertia. Then J is the total angular momentum. So in these cases, from this equation we have to define then wave number can be right like this. Then del is equal to hc. So ordinary energy joules varum. Then we have to convert then wave number. The unit will be centimeter per minus 1. So after we have to apply wave number into this equation, then we have to get this equation. So finally we have to take this one is a b, j plus 1, where b is the rotational constant. So இது தான் rotational constant. இதுவும் நிறைய டைம் கேட்பாங்க. Okay. So next frequency of rotational spectral line we can write like this. So in general the spectral line can arise from j to j plus 1. So this is the most important. இதுவும் நிறைய டைம் கேட்பாங்க. Which one is correct for frequency rotation spectrum line? Then 2b j plus 1. It should be vary for non-rotating rotator like this. So what is the selection rule for rigidity diatomic molecules? In diatomic molecules del j is equal to plus or minus 1. Okay, so the transition or per minute there is a increase or decrease by unit now 1. So in this case some of the bond length, these are also most important. Then carbon monoxide, then HCl, HI value. So இதெல்லாம் repeated கேட்குற questions. Okay. So next non-rigidity diatomic molecule. முன்னாடி rigidity பார்த்தோம், இப்போ non-rigidity diatomic molecules. So then non-rigidity molecules same அதே தான் rotational constant வரும். இங்கே வந்து we have to add this term. Okay. அப்போ then after we have to apply then wave number, we have to get this equation. So இந்த equation நம்ம ஏற்கனவே rigidity diatomic moleculesல பார்த்தோம். இது வந்து that is called distortion constant. அப்போ B and D are constant. So அப்போ B க்கு இந்த value, then D க்கு இந்த value. Okay. So finally we have to take some of the values. Then K is equal to force constant. So from this equation we have to find out then D. Okay. So then vibration frequency is the order of 10 power 3. In cases of B rotational spectrum is the order of 10 power 6. So இது ரெண்டுமே most important cases. Okay. So then vibrating diatomic molecules. So then Hooke's law can be defined then stress by strain this is the formula, then E is equal to 1 by 2k, then R minus RQ by 2. So இதுமே நம்ம harmonic oscillatorல இந்த equation நம்ம படிச்சிருப்போம் quantum mechanicsல. So then vibrating diatomic molecules it also called as simple harmonic oscillator. So this can be right in this equation. The oscillating frequency can be right like this. So if you take wave number, we have to put one of the C. Then after that we have to find out the vibration energy. Then after we have to applying then wave number. Then finally we have to get this one. So it is called 0 point energy. So in this cases the translation and rotational causes still vibration motion can occur. Okay. So if it kinetic energy or translation occurs means so finally then k is equal to 1 by 2 m b square போடுங்க இங்க translation motion நால then x dot square plus y dot square plus z dot square. So then selection rule for vibrating diatomic molecule then del v is equal to plus or minus 1. So these are all the some of the cases we have to find from the previous one. Then frequency of spectral line, then same one we have to follow in these cases also. Then what are the instrumentation of microwave spectroscopy? First one, source and monochromator. What is the source? Then reflex ultrasound. So these are also readily available from 3000 to 5000 and weakest signal up to available those values. Those cases obtained in the harmonic generator. Okay. So next beam direction, then simple and sample space, then detector, then spectrum analyzer by using CRO and ink recorder. So what are the applications? First one is structural determination, then microwave oven. So these are all the most important. Time kepanga. Okay. So next then difference between the IR and microwave. So in microwave la we have to characteristic of observing molecule. In IR like characteristics of functional group. So the resolution of line in microwave is very much greater than IR. In microwave gaseous state, in IR la solid liquid gaseous state. So இதெல்லாம் most important. இதெல்லாம் I have given those point which is related to the exam. So exam point la நான் கொஞ்சம் short கொடுத்திருக்கேன். Okay. So next vibrational spectra or IR spectra. So vibration spectra is one of the most powerful technique for chemical identification. It is a quantitative analysis. So in IR then comparing to other method it should be useful for X-ray diffraction, then electron spin, resonance, etc. So the molecules of chemical suspense then vibrate at many rate of vibration which is give rise to a closed back absorption which is called IR absorption spectrum. So the spectrum of a chemical suspense it is used for fingerprint identification. So then V is equal to then C by wavelength. So from wave number we have to write 1 by wavelength which is equal to V by C. So the wave number is reciprocal of wavelength. So this is the most important. In the time கேட்டிருக்காங்க. So what is by transmittance and absorption? So then band intensity of IR spectrum may be either transmission and absorption. So transmission and absorption எதுக்கு வருதுன்னா in IR spectrum. So then transmission can be defined which is the ratio of radiant power transmitted by the sample to the ratio of power incident on the sample can be write A is equal to the logarithmic power 10 of 1 by T. So இது நிறைய டைம் question கேட்டிருக்காங்க. Okay. So okay. Okay, good. So then what is the IR range? So IR lies between visible and microwave region. So in photographic region visible which is equal to 1.2 this value, then very near IR region this value, then near IR region this value, then far IR region which is called as rotational region. So IR region we have to get from microns, then wave number this value to this value. So unharmonic oscillator which is similar to we have to discuss before, then rigidity and non-rigidity, then diatomic vibrating rotator. Then similar cases we have to follow in this unharmonic oscillator also. This is the general equation. So in these cases then A is a constant, then D is the dissociation constant. So we have to finally we have to get then 0 point energy from the previous cases. Then vibrating diatomic molecules we have to get then E naught which is equal to 1 by 2 those values. Similar cases we have to follow. Then selection rule, then del B is equal to plus or minus 1, plus or minus 2, plus or minus 3. If plus 1 na considerably intensity, then finally we get this wavelength. If plus 2 na small intensity, we get this value. If plus 3, it should be normally negligible intensity. If plus 1, then normally very weak. So இதெல்லாம் most important. நிறைய வேலை இதெல்லாம் கேட்பாங்க. Okay, good. So if weak absorption are called hot band. One of the condition is high temperature. If the temperature is rises, the hot band will increase in intensity. So it is most important. Okay, so next case is diatomic vibrating rotator. So the diatomic molecules can execute both rotation and vibration simultaneously. This is the total energy. Then after we have to apply then wave number, we have to already know the rotation and vibration energy. We have to combine all the equation, which is called as the total energy. The selection rule, then plus or minus 1, plus or minus 2. If it del J is equal to plus 1, we have to get this equation. So from this equation we have to put plus 1 and minus 1. We have to get this equation. So in this case then line arises from del J is equal to minus 2, minus 1, 0, plus 1, plus 2. Now we have to get these cases. Okay, so then linear molecules. So in linear molecules it possesses only the permanent electric dipole momentum or not, means if I are active. So in linear molecules vibration produced in oxidating dipole. So in case of CO2, then two types we have to occur, that should be IR vibration. So first cases, if it parallel, means the selection rule we have to get. Similarly vibrating and rotator we have to get. Then CO2 we have to identify by using the arrow marks. Then similar for perpendicular, we have to get this one. So if del J is equal to 0, we get a new group of line which is called branch. So then Raman spectra is a visible region. Then what is meant by a Rayleigh scattering? The frequency of scattered light is same as that of frequency of incident radiation, which is called Rayleigh scattering. இது நிறைய டைம் கேட்டிருக்காங்க. So what is meant by a Raman effect? In 1928 இதுவே கேட்டிருக்காங்க. In 1928 year, in which year Raman should find out the monochromatic beam of light by using solid liquid gas, which year? 1928. So in 1928 C.V. Raman, by using a monochromatic light, it is allowed to pass through a solid liquid gases. He observed a scattered light contain some additional force through the instant frequency, which is called as Raman effect. So those lines having wavelength modified by Raman, it is called as Raman lines. So if it lines are greater wavelength, that is called Stokes line. If it's shorter wavelength are called anti-Stokes line. This is the Raman shift. So I hope this video is useful. So spectroscopy part 1 முடிச்சிருக்கோம். Part 2 video remaining topic முடிச்சிட்டா we have to complete the spectroscopy. Okay, so இப்போ இன்னைக்கு என்னென்னலாம் பார்த்துருக்கோம்? ஸோ பார்த்தீங்கன்னா ஸ்பெக்ட்ரோஸ்கோப்பியில் மாலிகுலர் ஸ்பெக்ட்ரானா என்னன்னு பார்த்துருக்கோம். So next diatomic molecules, then rigidity diatomic molecules. So இதெல்லாம் most important. இதுவுமே most important. அப்புறம் then frequency of rotational spectra, then selection rule. Then அதுக்கப்புறம் பார்த்தீங்கன்னா then non-rigidity diatomic molecules, then vibrating diatomic molecules. So then instrumentation of microwave spectroscopy, then applications, then difference between the IR and microwave. So next vibration spectra IR பார்த்தோம். Next transmission and absorption. So next IR ranges பார்த்தோம். Next anharmonic oscillator. So next diatomic vibrating rotator. So next linear molecules. So next Raman spectra. ஸோ நண்பர்களே, இந்த வீடியோ நான் எதுக்கு போடுறேன்னு பார்த்தீங்கன்னா, ரொம்ப ஷார்ட் பண்ணி தான் நான் போட்டிருக்கேன். புரியுதுங்களா? நீங்கள் ரொம்ப வந்து இதெல்லாம் பண்ண வேணாம். நான் சொல்கிற நோட்ஸ் நீங்கள் ஃபாலோ பண்ணிங்கன்னா டெஃபினெட்லாக ஃபிசிக்ஸ் மேஜர் பொறுத்தவரையும் 110க்கு 75லேருந்து 80 வாங்கலாம். நீங்கள் நம்ம வீடியோ ஃபாலோ பண்ணிங்கன்னா ஓகே. டெஃபினட்டாக அதுக்கு மட்டும் நான் அஷ்யூர் பண்ணுறேன். நீங்கள் நம்ம வீடியோ ஃபாலோ பண்ணி நோட்ஸ் எடுத்தீங்கன்னா 110க்கு 75லேருந்து 80 கன்ஃபார்மாக வாங்கலாம் நண்பர்களே. ஓகே. ஸோ இந்த வீடியோ பிடிச்சிருந்தால் லைக் பண்ணுங்கள், உங்கள் நண்பர்களும் ஷேர் பண்ணுங்கள். முக்கியமாக உங்கள் சஜஷனை கமெண்ட் பாக்ஸில் கமெண்ட் பண்ணுங்கள் நண்பர்கள். மீண்டும் ஒரு வீடியோவில் சந்திப்போம். நன்றி, வணக்கம்.